So we started off today with a time where you could ask any question that you wanted about the top 20, and the first one that came up is like this. I don't want to do the exact one on the page because a lot of you have already done it and you won't care. Oh, sorry, number 8. Yep, and it's about exponents. So I'm going to make something very similar but a little different. 3n squared x to the third. All of that squared times 8n x to the fourth. All right, everybody chew on that for just a second and tell me, how do you start? Because if you don't know how to start, obviously, that's the first step. How do you start? Sam, how do you start?
You distribute the square in
Okay.
parentheses, so then it would be 3 squared times
3 squared is 9.
n squared
N squared. And it's really hard to know whether he just did 2 squared or the 2 times the 2, because they're different. So he'll be able to tell by the last one he does. Because if he says it's x to the 9th, then you know he's doing 3 squared. If he says x to the 6th, you will know that he's multiplying the powers. And if he says x to the 5th, you will know if he added the powers. And do you get with 2's? You can't tell which he did. Because 2 squared is 4, and 2 plus 2 is 4. And 2 times 2 is 4. Okay, so anyway. Now we'll be able to find out, what do you think?
And then x cubed squared would be x to the power of 3 times 2.
All right, I just found a typo in my, sorry. Okay, so final, you times them, and so it's x to the?
6.
You are correct, sir. All right, now that's something that a lot of people don't know. And then this 8 here, I get a lot of people feel like that 8 is like married to this group over here, that the 8 and the n and the x squared all have this special relationship, and they do not. These can now be rearranged any way you want. That 8 could be moved over in front of the 9, and then it'll just be 8 times 9. You can do that. Because why? Because this is all a big times problem. And if things are times, you can move them around. It's called the commutative property. You can commute, as in move. So you can move the numbers all around. So I'm going to move those there. I'm going to move the n's next to the other n's. So I'll just say times n. And I'll move the x to the fourth. Well, I think you can imagine I could put it right there next to the x to the sixth. And then my final answer would be 72. N to the, is that the kind where I add the powers or multiply the powers? Add them. So n to the fifth. And the last one is x to the 10. If you're like, how do you know whether you should add them or not? Well, if it's like x to the third to the fourth, if you write out what it really means, sometimes that helps. X to the third means that. And then if I put it to the fourth, do you get there's going to be 4 like that? So if there's 4 of them like that, then it's 4 times 3 is 12. And you could go back to this and go, oh, so I just multiply that kind. Yeah. So if you write out what it really means, that can help. Okay, so this 6 and this 4 got added to the 10th. Any questions on that kind? All right, I know which ones are missed the most, but I'd rather answer the ones you want to know. Yes?
9.
Read me number 9. Just the start of it.
2/3 a plus 3.
Ah. All right, I'm going to make one similar to this. I'm going to make it 1/5. And the words clear fraction are in there, and then it says solve. Well, which is it? Well, both. Because if you solve it, you want to get a alone. But to get a alone, the best way to do it is to clear the fractions. A lot of people start this one by subtracting 3. Don't start this by subtracting 3. Why? Because when you are now at a higher level math class than you've ever been before, and you need to learn to clear fractions out. Fractions aren't incredibly hard, but would you agree problems without fractions are easier? So you want to clear the fractions out. So how do I get the fractions out? I just times everything by 3. Notice everything by 3. I can't just times one of these two things by 3. It's kind of like I had a 3 in front and I distributed it to both. Okay, so I'm multiplying by 3. Why did I do that? Because then that 3 will cancel this other 3. The 3 on the top and the 3 on the bottom will cancel. But wait, I want to do this as fast as possible, server, because this is a test and I have a time test. So then, at the same time, multiply it by the other denominator, which is 5. And some people will say, but can I just have multiplied by 15 through the whole thing? Yeah, but it's actually worse. Do you remember my saying, if you can factor it, you should? And 5 times 3 is 15. So it's smarter to use 5 times 3. Why? Because look, cancel, cancel. I already have the answer of 3. Cancel, cancel. And now I have the answer of 10a. 10a plus 5 times 3 is 15 times 3 is 45 equals 1 times 3 is 3. And do you get from here, I can say that's easy. Subtract 45 divided by 10. So it's a moral of the story. If you see fractions, clear them. I've already hit you with 2 things you're going to use over and over in my class. And you might not even notice it, but if you can factor it, you should. And the second thing is, if you have fractions, clear them. Those are 2 things that keep coming up. I'm telling you, we'll have all you 30 really smart kids sitting in one class, and I'll say, so what's next? What do you think we should do next? And most people will be like, I don't even have a clue what I should do next. And what will the answer be? You should factor it. It ends up happening. I'm telling you, you'll all be sitting here, you'll all be stuck, and then maybe Sam will go, oh, we can factor it. So try to catch it earlier then. And that way on your tests, you can do the same thing. Almost always there's a test question in the first couple tests where the key is, if the kid figures out that they can factor it, then it'll be like, oh, this cancels and this cancels. The problem's easy from there. You just got to remember, when you're stuck, think about either clearing fractions or if you can factor it, you should. So let's see if you really caught that. 4/5 n plus 1 over x is equal to 2. That looks different than you just did. Yeah, but you can use the same principle I just taught you. Clear the fractions out and solve for, well, which one? There's 2 variables in that. I want you to solve for n. Who knew that they needed to times by 5? Good. Who knew that they also needed to times by x? Good. You're timesing by 5x through the whole thing. And sometimes things just straight up cancel, like boom, those 5's canceled, yay. 4xn. And it does not matter if it's nx or xn, don't care. This x and this x canceled, which is cool. Okay, so now I'm just down to plus 5 equals 10x. What was I supposed to solve for? N. So that should tell you what to do next. If I want n alone, there's only one of those n's. It's right there. If I want that alone, do you get you're supposed to subtract 5? 4xn equals 10x minus 5. Now I'm going to divide everything by something, and the n will be alone. What am I dividing by? 4x. So that was much more intense than the one that's on the top 20, Mr. Server. That's why you need to know the top 20 skill, is because later we'll be doing that. And there's variables all over the place, but you still just multiply by the denominator. Okay. It'd been a lot easier to just say, here's another top 20, go for it. But I'm taking time, respect that, and ask me, use this time. Is there anything else that's on the top 20 that you're probably going to get wrong and you take it home for homework? You sure? Yes.
Number 6.
Okay, read it to me.
P equals 2L plus 2W F over W.
Oh, and that's part of it, is just the wording of it. I get this is confusing. What they're trying to say is solve that for W. So all they're saying is, here's your equation, solve it for W. So to start with, what's it solved for right now? P. If I want to solve for W, then I want this alone. I have a startling number of people that think you start by dividing by 2L. You don't.
What? Huh?
What do you do? Just get W alone.
Subtract.
Subtract 2L. subtract 2L. Why? Because the 2L is being added right now, so you subtract 2L. And now it's P minus 2L. You can't be expected to know what that is, so you just leave it the way it is. And then you just divide everything by 2. But at this moment, I have a choice. I can divide it all by 2 like that, which is legal. P minus 2L over 2 is a legal answer. Or you can separately divide them and say P over 2 minus 2L over 2. And do you see that gives you an extra opportunity to cancel something? But it's not like I'm saying it's better. I'm just saying that's right. And that's even more right, kind of, because it got something to cancel. But either way is okay. I'd accept either answer. All right, that's called a literal equation. Ever heard of E equals mc squared? Einstein's equation. But it involves the speed of light. You know which part is the speed of light? The c. E equals mc squared. I'd like you to just tell me, what's it solved for right now? E. And do you know what it's in terms of? So when this is an important terminology. If I say it's solved for E, it's in terms of M and C. In terms of means what things are in the answer. It's got M's and C's in the answer. So if I say it's solved for E, you also have to know it's in terms of M and C. So here's the directions off the ACT. I'm not saying this will be on there, but it could be for sure. Solve for M in terms of E and C. Try it. Solve for M in terms of E and C. That just means that E and C will be in your answer. Maybe a little too easy, huh? Just want M alone, you just have to divide by C squared. There you go. Oh wait, I just crossed the wrong thing out at the end. There we go. E over C squared. It's just as good in an equation. I mean, it's just rearranged. All right, what would have been a lot harder to solve for?
C.
Everybody solve for C, please. And this one, when you solve for C, just be careful. And check with the kid next to you when you're done. All right, I need to go get some new cards. And the name tags, store and rearrange it.
Oh, wait. C is positive. Yeah. It can have negative C though. It's true. It's below C, you cannot have negative C. Technically, it was, you can have a negative C. You can't have negative C. For velocity. Energy equation, technically, you can't have negative speed. It is not direction. Well, it was, I'm going to go say that. And or something else. There's no amount of
Okay. Did you divide by M? And you might have thought, well, that's pretty easy. And then did you put it to the power of 1/2? Is there any chance that you did that? Because that would work. But you might think, what the heck is this power of 1/2? What is it called? It's just the square root. If you did that, it's cool, but there's something missing from the final answer.
Plus or minus.
Plus and minus, you are correct. Here's why. Because if I do a square root symbol, it might make it easier to see. Square root instead of the 1/2. Square root. When you do the square root of a variable, you get the absolute value of the variable. Remember me telling you this before? So that's actually the absolute value of c equals the square root of e over m. And that means that you have a plus and a minus on your final answer. C is actually two things. C is the square root of e over m, and C is the opposite of that. So you can go plus and minus. All right, I know that's confusing, and it comes down to this. Back in middle school, you were probably taught you can square root both sides, and then A equals, and then they tried to say 16 is really plus and minus 4. It's not. Square root of 16 is not two things. It's just 4. So then how come we know there's two answers, 4 and negative 4? It's because that's an absolute value. And a lot of people skip over that step, but now I have to reteach it to you because you need to know that. You square root a variable, you get the absolute value of the variable. Okay. So you forget that plus minus, that's going to cost you points on at least 3 tests this year. 3 tests, 3 times on a test. You're going to be square rooting a variable, and hopefully you'll be like, ooh, this is one of those moments, one of the 3 times where I got to remember the plus minus. Yes?
But then the speed of light can't be negative.
Okay, now you're getting me with context. The speed of light can't be negative is what she's saying. That's a very good point because she knew what C was. So there are times when this is the right answer, but you have to throw out one of the right answers because, thank you so much.
You're welcome.
Because you know that by context, it's not possible. Another one will be, we'll have answers where the time that Jimmy, like was supposed to catch the ball would be at time 2 seconds or at time negative 1 seconds. Can time be negative? No. At least we haven't learned to go back in time yet. Maybe someday. So then you have to throw out one of your answers, and that's called an extraneous answer. Dang, this class is complicated. So you have 2 answers, but yet you have to throw out the other one. So I know some of you are going to be like, well, I just only included the positive one in the first place. That's not better. That means you just forgot. Okay, so if you had both answers, and then you said, but I'm overruling that and crossing this off and saying it's because it's EXT, that's the perfect answer. You knew that it should be plus and minus, but you said technically C can't be negative because it's the speed of light, so I'm going to say that's an EXT answer. Does anybody remember the word for EXT? Extraneous. Who in here needs another name tag because somehow yours is somewhere else? I don't get what happened, but please let me give you another one.
Oh, I'm good. I'm not fine. I
All
just
right.
have to take that out.
I am the one who really needs them. I apologize. Well, there's too many of you. This is crazy. I'm going to hold that thought a second. I'm going to find the stack that's got your names in it. It's not those. You guys have already looked through that stack, right? Would you be willing to come up here? Yours will be in here somewhere. Can you see if, because they all got put in the same hour by accident. Can you see if it's in there? Just look through those for a minute. Okay. Let's get to the last student chosen top 20 that I should do. Yes.
18.
Problem number 18. Can you tell me what that's about? Over what?
Over 3.
Okay. So this is a trap. First of all, it's trying to catch kids who want to do that. Can you cancel those two? No, because it's part of an add subtract problem. If you still don't get why that is, it's because if I add 4 plus 5 over 4, can I cancel the 4s and the answer is just 5? No, it's 9 over 4. That's not the same as 5. You can't cancel when they're like that. That doesn't work. So that's the first thing, is you can't cancel those 3s. Okay, next I'd like to just try the next one. That's awesome. You'll find one of those is where somehow All of them were put it this way. Wait, it's not that hard. There you go. This is the next thing that has to be done. The square root of 27 has to be simplified into 2 square roots. 9 and 3 would be my choice because one of those is perfect. 3 is. This is 3 root 3. Do you guys feel like you can do that? Square root of 27 turns into 3 root 3. You got that part? Okay, then here's the last part. These both have a 3 in them. They can be factored out. What's the good part of that? You now can cancel those 3's. But first you got to get it factored out and put it here and there and a plus minus in between. So 3 comes out of this and you have negative 1 left. 3 comes out of that and you have the square root of 3 left. And then those cancel. Does that make sense to you? Okay, so it's a 3-step process. Simplify the square root, factor something out, and then cancel that stuff. That's something. All right. Oh, excellent. Thank you so much. I'm going to do... And how about we have everybody come up and get their own? It'll be much easier. Wait, I got to keep these separate though. Vega, yours is up here. Clara, yours is up here. We found them. McLean's up here. Jaden's up here. Nolan's up here. You can pretty much come up here if you don't have your name tag. We have found it. Actually, Mira has found it. Thank you for doing that. So here's the review part of the stuff we've learned since the beginning of the year. Here's a kind of complicated one. Set of x comma y where x is greater than 2 is unioned with y is less than or equal to 3. That is a x and y graph kind of scenario, and you'd have to graph exactly what's included there. These are picky. You put a dotted line where there's supposed to be a solid line, you get it wrong. You shade in too much or shoot too little, you get it wrong. I see a cell phone out. I see 2. Could you put them away, please? They need to go in a backpack, not in your lap. That's not away. We will have some time at the very end of the hour where you can take the cell phones back out. I'm going to give you one more to work on. In a triple Venn, where it's A, B, and C, I'd like you to try to shade in not A, union, not B, intersected with C. I'll pause for a second. Let me try that. So here's x is greater than 2, shaded that way. Next, y is less than or equal to 3. Notice I have to have a solid line where y was 3, and less than that means shaded underneath that. I'm going to shade like this. Now, is the answer where it's overlapping, as in intersecting, or is the answer all of that that's shaded? Everything that's been shaded. If it had only meant where they overlapped, I would have had to have an upside down U if I had wanted the intersect part. Okay, then the other one here for practice, not A. I'm going to do like this. That's not A. And then union, not B. Not B, being shaded in blue. This means everything that's been shaded. Can you tell me, is there anything that hasn't been shaded? Yeah. Okay, and that's those 2 little sections right there. Those weren't shaded. Okay, Now it's intersect with C. So here's the C, but I'm gonna, on purpose, since I know it's intersect, this is your answer. And the reason that one little centerpiece isn't in there is because it wasn't in this group. So the final answer is just the green. Raise your hand if you had that one right. Cool, I think you're getting those. Now, for tonight's homework, it's just I'm gonna put in every skill of the top 20. So far, I'm up to number 4. I'm gonna just keep pumping them in there, and they're only 1-question quizzes, and you just keep doing them until you've done all 20. Okay, you don't have to repeat them until you get them right, but ideal world, if you get one wrong and you figure out by looking at the answer, go back and do it again, and you get the last score. So this one is not an average. This one's just, if you get it wrong, you get a new, different question, which is kind of ideal. You get a different question, and you get a second chance to get full credit on that question. All right, so that's your only homework for tonight. And we'll get back into learning new stuff again tomorrow. That's all I got for you for today.